Here we have a graphics card, EVGA GTX 1080 Ti. We already disassembled the video card and it's not working. Let's read what the customer wrote. This is an expedited service. Customer is paying $49 more so we can do this as soon as possible. Graphics card is not recognized by system and doesn't send signal to monitor. Temperature LED on top is flashing red and green, implying some thermal issue. All right, so the card is not recognized, just like every card that we get in the shop here. Let's do quick measurements before we plug this in and measure some voltages. We're going to start with the 12 volt line where we plug the connectors. 12 volts, 12 volts. And we're going to measure 12 volts at the inductors here. And we're going to also measure if you have a short on 12 volts at the base here. We're going to measure 3.3 volts. We're going to measure 5 volts, 1.8 volts, the PAX rail, the memory rail, and we'll see what's going on. Okay, so meter in continuity mode. And we're going to go ahead and measure the first 12 volt inductor here, the first connector. And we do not have a short. And the second one here, we do not have a short. I'm going to measure all inductors and see if we have a short anywhere. In the meantime, we're going to be doing physical inspection on the board and see if there's anything blown, anything discolored, any component ripped off the board. Just quick physical inspection. And while at it, why not just quickly test this? And of course, resistance here should be very low, like probably 0.2 ohms. If you look at the GPU, just inspect the surrounding here. No burn marks. Let's go ahead and measure our PCIe 12 volt on the base here. Any one of the 3 pins. Meter in continuity mode, and we do not have a short. What about our 3.3 volt line? And we do not have a short. So no short anywhere on the board. Right now, the way I see it, we do not have a short anywhere on the board. And that's a good thing. A short on 1.8 volt rail is likely a dead GPU. A short on a PAX rail is likely a dead GPU. So there are a lot of things that can kill the GPU, but right now I do not see any reason to think that we have a dead GPU. Data capacitors are all present and everything looks good. So I feel good about this card. I feel like it's fixable. All right, so what we're going to do is plug it in and measure some voltages. Turn the power supply on, and we're going to turn on the board. And we're going to start measuring. Now, if the card is not being detected by the motherboard, then it's going to beep 6 times, like it's doing now. I need to have a zoomed in camera here so you can see what I'm measuring. Meter in voltage mode. And let's see. 12 volts on the first coil we have. 12 volts on the second coil we have. We have 5 volts. And 0 volts on this second coil here. What about our memory coil? Any voltage there? 0 volts. 0 volts on memory. Our packs, 0 volts on packs. So we are missing 1.8 volts. We are missing our packs, and of course we are missing our memory. Let me quickly take a look at the resistance on the memory inductors here. What do we get? 2.8 ohms. Wow, that's very low, extremely low, scary low. And if we measure pin number 1 here, 3.5 ohms. That's extremely low. What about the second one? 117K, which is okay. So right off the bat, we see that we have a problem with the MOSFET, the top one. So let's go ahead and replace that MOSFET and see what happens. All right, so the MOSFET is out. And now if we put meter in resistance mode, let's go ahead and measure. And now we are getting 120 kilo ohms. 120 kilo ohms, look at this. Now the reading, let's do this. Now the reading is 120 kilo ohms and not 3 ohms. Look at this. 121K, which is similar to its sister right here, the one next to it. Or he could be her brother and not sister. 116K and 121K. Let's replace that MOSFET and see what happens. We got a lot of packages today, a lot of packages. We have a lot of work to do. Somebody was asking, do you ever take a vacation? I mean, I wish. I like to take vacations. I like to go on long road trips. I like to take at least 1 week off, but right now I cannot. If I take 1 week off and we get 30 packages a day, I'll come back with 210 packages waiting to get done. I honestly do not know what to do. I do not know what to do because I'm stuck. I'm stuck and I cannot tell myself that screw it, I'm just gonna go and whatever happens, happens. I cannot do that. I have to figure it out, how to free time for myself. I'm not able to find anybody local that does this type of work, so I'm stuck here myself, big boss. And my dad is the person who handles all e-commerce and shipping. So this is a good MOSFET. And just let it flow. All right, so let's go ahead and test pin number 1 and see what readings we get. And 111 kilo ohms. Okay. 112 kilo ohms. Perfect. Okay, so let's see what's going on here. Right now we are not getting any voltage reading on this inductor. Our 5-volt inductor is here and we are getting a reading. And if we measure those 0 ohm resistors, what do we get? They're good, they're good. And of course we don't have a short, because if we go to diode mode and we try to measure for a short, we will not get a short. Look at this, 0.452 voltage drop. And what could be causing no voltage on this coil? Let's measure this fuse here. Meter in ohms mode. I just want to see how many ohms this fuse reads. 14 mega ohms. We have a blown fuse. We have a blown fuse. So right now it's showing 11, 12, 13, 14, 15, 16 mega ohms, and it's still going up. What I'm going to do is apply solder on top of this fuse, and we're gonna jump that fuse. Okay, so that should be enough. Just temporary. We can replace that fuse later on, but it's clear that we have a blown fuse. Meter in continuity mode, and let's see. It's good now. Let me test all 0 ohm resistors on this board. And look at that. 0 ohm resistor is reading 455 ohms. 455 ohms. 455 ohms. And look at that here. We have a crack on this capacitor. Let's put it in continuity mode, and this capacitor should not be continuous. And look at this. Meter in diode mode, red probe on ground, and let's see if we have a short. And we do. Flip the probes. And we do. We have a short on this cap. What else is wrong with this board? What else? Okay, so that component is out. And let's see if we still have a short. And we still have a short. Let's measure in resistance mode and see what we got. So I'm reading 0 ohm, and I'm reading 0 ohm. We should be reading 0 ohm on ground, which is this one, but not here. Maybe we can inject 1 volt right on that pad and see what gets hot on the board. I think that would be the best option. I'm going to use our voltage injection tool here. I'm going to set this to 1 volt and maximum current 3.5 amps. I do not really need to limit current, but it's already set at 3.5. We can increase or decrease it. And I'm going to monitor the board under a thermal cam and see what gets hot. So we're going to inject voltage at that point of the diode, at the positive side of the diode that is currently shorted to ground. And we're going to monitor to see what gets hot on the board. Right now, I'm not going to be able to show you what's going on the thermal cam. Usually I can switch you over to the thermal cam to see what's going on, but the cable got damaged. We ordered another one, we got it, but the problem turned out to be the RCA to HDMI box. We have one on order, and we should receive it in a couple of days. So right now, I'm going to inject 1 volt onto that positive side, that shorted positive side of the diode. And under the thermal cam, we're going to see what gets hot. I mean, look at this. When I put the probe onto that point, our voltage injection tool is drawing 3.3 amps. And I can already see what's getting hot on the board when that probe hits that pad. Right there, right there. So we have the second MOSFET from the top. Okay, the second MOSFET from the top. 1, 2. That's probably what's causing the short. So you were not able to see the thermal cam, but I did see it. I injected 1 volt right over here at this point. Our voltage injection tool displayed 3.5 amps being drawn by that board. And checking the board under the thermal cam, this second MOSFET from the top got hot. This one here. Let's go ahead and remove it. I mean, before we remove it, let me just do some quick measurements. I just want to see the difference between this one and the one on top. Meter in diode mode, I'm getting 0.44. Actually a short. Look at this, I'm getting a short here. So exactly like the thermal camera indicated, a heat spot here. What about this one? This one also. We may have a problem with both MOSFETs. What about this one? This one is good. So look at this. We have a short here and a short here. Okay, so that's good news, because it could be either one of those two MOSFETs, or maybe both of them. I'm going to start by removing this one. The heat spot on the thermal camera was visible on this one here. But this one is also measuring a short. So it could be either one or both. Okay. So let's put it on the side and measure quickly and see if we still have a short. Meter in continuity mode. Do we still have a short? And look at that, the short is gone. The short is gone. So it's that MOSFET. The thermal camera displayed heat on that MOSFET. And look at this, the meter is reading 347 ohms now, 347 ohms rather than at that short. We have to replace that MOSFET, we have to replace the diode, and we have to replace all 3 0-ohm resistors. After doing so, this video card should work, because if it doesn't, I'm going home. That's it. I'm gonna take a break, drink some water, stretch out, and I'll be back. Let's go ahead and replace that MOSFET. And again, we are applying Amtech 559 Flux. You can purchase Flux off our website. We are one of the major resellers of Amtech Flux. So let's test one more time. Just make sure we do not have a short here. Meter in continuity mode. And perfect. We do not have a short. And the meter is reading 424 ohms. Awesome. Amazing. We are on our way to getting this video card fixed. I hope nothing else is wrong with this board. If what I just did does not fix the problem, then we're gonna call it quits on this video card and move on with our lives. Okay, let me keep this one for now. So let's grab a size 805 0 ohm resistor, and I'm pretty sure this is an 805 resistor. And yes, perfect. I grabbed two of them and we still need one more. Exactly the same size. And let's remove this last one here. I kept it so I can compare the size. We're gonna secure this resistor from one end, and then we will apply heat. And one more. All right, now we can reflow all those resistors down in place. That's it, we are all good. We can make those resistors look nice and pretty. We do not have to. And now we have to grab a diode. And now we have to grab a capacitor that looks like this. I think I called it diode previously. I just realized I called it diode. It's a capacitor, not diode. Okay, very nice. And all we have to do right now is test. So right now, whether this works or not, this will be the last thing that I will be doing for today, and I'm not gonna spend any more time on it. I mean, I really have high hopes on fixing this card. But right now I tried a lot of things, and it just comes to a point where you cannot spend any more time working on one single board. What did we do? We replaced the MOSFET. We jumped the fuse. We replaced 3 0 ohm resistors. We replaced the capacitor. I mean, what else? What else? Goggles, just in case. And I'm gonna keep my hand on the power supply again, just in case. And power it on. Last time we got 6 beeps because the card was not being detected, and it looks like we are not getting 6 beeps right now. That's awesome news. The video card is being detected now, but black screen. Right now, before we worked on the card, we had a missing 5-volt rail on the right side. We have 2 coils, and both of them are 5 volts, 5 and 5. One of them was missing and the other one was there. So let's test the one that was missing and see if we have 5 volts there. Now look at that, we have 5 volts. So that rail is fixed. And the other one we have 5 volts also. If we measure our memory, we have nothing. We have nothing. Our 1.8 volt is there, and it wasn't there before. We have 1.8 volts now. So before we were missing one of the 5 volts, and we were missing 1.8 volts. Now we have both of them. Flux is fixed. 1 volt. So we restored 5 volts, 1.8 and 1. Flux is reading 1 volt now. But our memory remains missing. So the only voltage that we have missing is our memory. V-core, we do not have anything. We should be reading 0.7 and we have 0. We do not have anything on our V-core. So V-core and VMEM are missing. I do not know what else to do. I honestly do not know what else to do. And just before we end the video, let me shut power off, and I want to test the resistance on VMEM and see what we get. And look at that, resistance went back to 3 ohms. I mean, we lost that MOSFET again. Let's measure here. We were measuring 110K. And right now, what are we measuring? Right now, it's back to 3.6 ohms. So something is blowing this chip. Right now, I do not know what's causing that chip to blow. If anyone worked on that card before, and you know what the problem could be, let me know. Leave it down in the comments. I do not know if we should rule this video card a no fix, or if this video card has a good GPU. I know that very low resistance here can indicate that GPU. Let me know if you have any suggestions, and maybe I can continue working on this video card tomorrow. But for now, I do not know what else to do. And that's it. I hope you enjoyed the video. Don't forget to like and subscribe. Leave a comment if you have any questions, and we'll do something else in the next video.